In this video, we're going to talk about solving systems by substitution. So this is a process when you have a system of equations, and if one of the variables is isolated, then you can use this method of substitution. So the first step in this process is to make sure that one variable is isolated. For a variable to be isolated means that it is by itself. So in this system of equations that's given, we have y on one side of the equation by itself. That means we can use the substitution method. Step 2 is to do the substitution. So since y is equal to 7x plus 14, that means that in the equation above it, anywhere we see a y, we can put 7x plus 14 in its place. So in this equation, where I see a y, I know that y is equal to 7x plus 14. So I'm going to rewrite this equation with 7x plus 14 being plugged in for y. That is the substitution step. Now we want to solve. So to solve this equation, I have to distribute this 4. So that gives us 10x plus, now 4 times 7x is 28x. 4 times 14 is 56. And then bring down the equals 18. Now we want to simplify. So this would be 10x plus 28x is 38x plus 56 equals 18. Now we need to subtract 18 on both sides. So 18 minus 56 is equal to negative 38. So we have 38x equals negative 38. Now I need to divide by 38 on both sides. So we get x equals negative 1. The third step in this process is to take that solution, x equals negative 1, and plug it back into one of the original equations. Okay, so I'm going to take x equals negative 1 and plug it back into either one of these equations. Since we've already found x, it would be helpful to plug x equals negative 1 into the second equation since we want to know what y is now. So let's take 7x plus 14 equals y. And I know that x is equal to negative 1 now. So I'm going to plug in negative 1 for x. And simplify. So 7 times negative 1 is negative 7 plus 14 equals y. Negative 7 plus 14 is positive 7. So we get positive 7 equals y. Now we can write our final solution as a point. So if our solution is an ordered pair x comma y, then our solution for this system of equations is -1, 7. And now we're going to do some guided examples using the substitution method. Remember that we always need one variable to be isolated. For a variable to be isolated just means that it's on one side of the equation by itself. So for number 1, in this system, we have one variable is isolated already. Since we have x equals is already isolated, since x is isolated, that means that we can go ahead and use the substitution method. So I'm going to rewrite these, and we're going to replace x with whatever it's equal to. Okay, so in this equation we have 3x minus y equals 14, but we already know that x is equal to 2y minus 2. And I'm putting that in parentheses because we're about to plug it in. So we're going to rewrite 3 times, instead of x, we're putting 2y minus 2 because x is equal to 2y minus 2. And we're finishing writing the rest of that equation. So now we're going to solve for y in this equation. So we've got to distribute this 3 first. 3 times 2y is 6y. 3 times -2 is -6. And then bring everything else down. Now we're at the process where we have to combine like terms. So we have 6y and minus y. So remember, this is like a -1 in front. So 6 minus 1 is 5y. Bring down the minus 6 equals 14. Now we need to isolate the 5y. So we've got to add 6 on both sides. So that eliminates. And we have 5y equals 14 plus 6 is 20. And finally, we're going to divide by 5 on both sides to get y by itself. 5 divided by 5 is 1. So we get y equals 20 divided by 5 is 4. All right, so now we know that y is 4. So if we know that y is 4, we can plug this in to one of these equations that we started with, either one of them. I'm going to plug it into the second one because now we want to know what x is. So since that second equation says x equals, that means it'll be a little bit easier if I plug in 4 for that y right there. So I'm going to come up here. And we've got x equals 2y minus 2. Well, we know that y is 4, so we're going to plug in 4 for y. Notice I put parentheses around it. Anytime I plug something in, we're going to put parentheses around it. So x equals 2 times 4 is 8, then minus 2. So x is equal to 6. All right, now notice our solution. Our solutions are points. Remember when we talked about graphing, your solution to a system is always the point where they intersect. So when we solve this system and we got x is 6 and y is 4, we can write that solution as a point. So our solution is the point xy. So x was 6, y was 4. And that's our final solution. All right, let's try another one. First, I want to see if I have a variable that's isolated. If I do have a variable that's isolated, then I can go ahead and use substitution. So now looking at this system, I can see that I have equals x right here. My x is on the right side of the equation, but that's fine. It doesn't matter if the isolated variable is on the left of the equal or if it's on the right of the equal, as long as you have a variable that's by itself on one side or the other. So in this one, x is isolated. So we can go ahead and use the substitution method. All right, so if I know that x is equal to 3 minus 2y, then that means I can look at the next equation and since I know that x is the same thing as 3 minus 2y, then I can rewrite this equation by plugging that in. So we have 2. Now instead of x, I'm writing 3 minus 2y. So I'm plugging that in with parentheses around it. Bring down the minus 3y equals 6. Now we've got to solve this equation for y. First, we need to distribute. So that would be 2 times 3 is 6. 2 times negative 2y is negative 4y. Bring down negative 3y and equal 6. Now we can combine like terms. We have negative 4y minus 3y. So negative 4 minus 3 is a negative 7y. So that gives us 6 minus 7y equals 6. Now we want to isolate the negative 7y. So we've got to subtract 6 on both sides to get rid of that 6. All right, so that eliminates. And we have negative 7y equals, now 6 minus 6 is 0. That's okay. When I solve for this, it's okay if you end up with a 0 somewhere. That happens sometimes. But when we've got to finish this out first, we can't just stop here. We've got to divide by negative 7 on both sides. Negative 7 divided by negative 7 is 1. So that gives us y equals. Now 0 divided by negative 7 is equal to 0. So now I know that y is equal to 0. So if I know that y is equal to 0, I can plug that into one of the equations I started with. So now I want to know what is x. So remember up here where I have equals x, I'm going to plug y into that equation because x is already by itself right there, and I want to know what x is. So I'm going to rewrite 3 minus 2y equals x, but now I know that y is 0. So I'm going to plug in 0 for y in parentheses. And now we simplify. 3 minus 2 times 0 is 0. And 3 minus 0 is 3. So 3 is x, or x is 3. Now again, all of our solutions are listed as points. So we have to write our solution as an ordered pair x, y. So x is 3 when y was 0. Let's look at some more examples. For number 3, what is the value of a in the solution to the system? So first of all, we need to realize that we don't need to find both answers necessarily. It's just asking us what is the value of a. So we've got to keep that in mind as we work through this. All right, well first I need to check to see if I have a variable that is isolated. If I do, then I can use substitution. So I see I have a equals. That means I can use substitution because a is isolated. So wherever I see an a in the other equation, I can put 3b plus 7 in its place. So I have 4a plus 9b equals 70. Well, I know that a is the same thing as 3b plus 7. So I can rewrite that, and I'm going to plug in 3b plus 7 in for a. So it's 4. Instead of a, we're putting 3b plus 7 and bring down the rest of that equation. Okay, so now we can solve for b. All right, so we've got to distribute some here. 4 times 3b and 4 times 7. So 4 times 3b is 12b. 4 times 7 is 28. And bring down the rest of the equation. All right, now I can combine like terms. I have 12b plus 9b. So 12 plus 9, that gives us 21. B plus 28 equals 70. All right, now I've got to isolate the variable here. So first I need to get rid of the 28 by subtracting it on both sides. All right, so that gives us 21b equals 70 minus 28 is 42. So divide by 21 on both sides. So b equals 2. Now, that's great, but we want to know what's the value of a. So once we know that b is 2, now we can plug in b wherever we see a b in one or the other of the first equations. So our original equations up here, I can pick either one of these and put b equals 2 in for b. All right, so if I've got a equals 3b plus 7, and I know that b is 2, then I can plug in 2 for b and simplify. So 3 times 2 is 6 plus 7, and 6 plus 7 is 13. So a is equal to 13. Let's look at number 4. What is the solution for the system of linear equations? So this one's asking for the whole point, x comma y, for the solution. All right, well, let's see. Do we have a variable that's isolated? If I'm looking up at the top, 2x is not isolated because of that coefficient of 2. We have to have just x or just y. So when I look at the second equation, I see y equals, so y is isolated. So that's what tells me we can use substitution. Okay, so looking up here at this first equation, we have 2x equals 11 plus y. Now, I know that y is equal to 4 minus x. So instead of y, I'm going to put 4 minus x in its place. And now we simplify, and we're going to solve for x in this equation. All right, so we got 2x equals 11 plus. Now, we don't have anything to distribute here. There's just an unwritten 1 in front of those parentheses, so that is just 4 minus x. And we simplify. If we can combine like terms over here, we want to do that. So 11 plus 4 is 15 minus x. Now we're trying to get we want all our x's to be on the same side. So we can add an x on both sides here. All right, so that eliminates, and we have 2x plus x is 3x equals 15, and divide by 3. So we get that x is equal to 5. So if x is equal to 5, then I can take that information and plug it in to one of the first equations. It doesn't matter which one, but if I want to know what y is now, then I have an equation that says y equals already. So I'm going to take x and plug it into that equation. So if x is 5, we're going to plug in 5 where x is. So 4 minus 5 is equal to negative 1. Now notice I can't just stop here because it didn't ask me just what x is or just what y is. We have to write the entire solution. So our solution as a point x comma y would be 5, negative 1.